Hello everyone, we will continue with this course evaluation of textile material, and today we will discuss another parameter which is extremely important for particularly for spun yarn, that is yarn and fabric hairiness. So, hairiness basically it is in most of the applications hairiness it is the property which is not desirable. Okay. Why I am saying it is most of the applications? There are some applications where fabric hairiness is required, particularly for some particular effect, or yarn in yarn hairiness some special effect if we need. In those applications hairiness is important, we need hairiness. In fabric we sometimes try to brush the fabric surface to get more and more hair to have certain special effect, velvet like effect, or to get some warmth or softness. Okay. And here in this class we will try to see the different aspects of hairiness, their causes or their effects, and also we will see the how to measure. There are different principles of measurement. We will see the different principles of measurement here. So, it is a most undesirable, most of the circumstances it is basically an undesirable property. We do not need, we need a yarn with free of hairs. Okay. And if at all some hairs are there, there are some techniques to eliminate this hair like singeing, shearing. So, these are the techniques, and the ring spun yarn like compact spun yarn is developed where the hairs are almost not there, it is almost absent. Problem is not only the visual appearance, but it gives problem with the production of fabric. In fabric production it creates problem and it deteriorates the fabric appearance due to that protruding hairs. It makes the fabric appearance dull. Okay. That is due to that random reflection, fabric looks a little bit dull. And now, how to measure the hairiness? It is actually there are various techniques I will discuss in detail. The measurement technique actually, depending on the techniques of measurement, the number of hairs or result changes. Okay. So, measurement of hairiness depend on the method chosen for detecting the hair. It can be number of hairs per unit length of yarn, or can be total length of hair protruding beyond the yarn surface. So, these techniques we will discuss here. Now, it is not possible to represent hair with a single parameter, okay, because the number of hairs and the length of hairs both vary independently. Okay. They are not dependent. Okay. So, length of hair, the thing is that suppose we have two yarns, yarn A having large number of hairs on the surface, but the lengths are smaller length, large number of hairs with smaller length. This is yarn A. Another yarn B is having fewer hairs but the length of hair are longer. Now, as far as the measurement technique, if we try to measure the length of hair, total length of hair protruding beyond the yarn surface, if we try to measure per unit length of yarn, suppose this is the unit length of yarn, here it is a unit length, and if we try to measure the length total, calculate the length of hair protruding. So, this total hairs 1, 2, 3, 4 whatever number of hairs, if we totally add all this hair length, okay, L I, this is the total length of hair in yarn A, and here if we add total length of hair L dash I in yarn B, and it may so happen these are equal, because if we add all this length of hair, here the smaller length or number of hairs more and larger length number of hairs are small, and if we add these two and then we try to find the total length of hairs protruding beyond the yarn surface, these are coming out to be same, equal, then our conclusion will be that hairiness of these two yarns are same. But problem is that the actual appearance or actual effect on different characteristics of fabric or processing performance will be entirely different. So, measurement of length may create some problem. On the so, to counteract this problem, what we can have? We can measure the number of hairs in terms of number of hairs protruding beyond certain specified length. Okay. So, suppose there are this is a length of 3 millimeter. So, we will try to measure the number of hairs more than 3 millimeter. Okay. So, this will give us an indication that the yarns are full of hair. Okay. And now, in that case this will actually differentiate between these two, but if we use that same technique here, same technique in this yarn B, same technique means the number of hairs beyond 3 millimeter, in that case the suppose this is say 10 millimeter. So, 12 millimeter, another yarn, another hair it is a 6 millimeter, another 4 millimeter, okay, 5 millimeter. In that case this technique of 3 millimeter, beyond 3 millimeter, this yarn will give the it is a all this hair will come into the picture. Okay. Now, this yarn B, now let us take another yarn, it is a C yarn with hairs which are just 3.5 millimeter. This hairs length are 3.5 millimeter. Now, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So, okay, let us say 5 hairs. Now, here also if we use 3 millimeter distance length of hair, this will give us the hair count, number of hairs per unit length, this is the unit length, number of hairs per unit length for both the yarns, it will give us 5. So, effectively actually this B and yarns they are in as far as hairiness is concerned, they are totally different in characteristics. So, this total methods of measurement, it creates problem and confusion. Okay. So, that we should be very careful in interpreting data. We have to see the which technique has been used. So, all this both the techniques are being used, but we have to see that which technique we cannot compare our result data from one instrument, one method to the result of other method. So, this problem of yarn C or this here, that can be solved to some extent by not by using only one that sensor, if we can use multiple sensors, which will give idea about the length distribution, length of hair distribution. Okay. Distribution of length, say more than 3 millimeter, how many this hairs are there, between 3 to 4 millimeter, how many hairs are there. So, like that one can get idea, detailed idea. Another problem of hairiness measurement is that, suppose if we measure in this method. So, what we see, the method of measurement by say length of hair, it gives us clear idea about the total length of hair appearance, whereas this measurement of total length of hair. So, one is the number based. So, this one is number based, this one again number based, number of hairs, but the principle which we have discussed, this is the total length of hair. Okay. Total length of hair we have measured here, but another problem with this number measurement is that, suppose the hairs are longer. Okay. Now, the hairs are longer hairs. Okay. Now, this is the hair. Okay. Now, if we want to measure the length of hairs protruding, number of hairs protruding beyond say 5 millimeter, we want to measure beyond 5 millimeter, what is the number of hair. In that case, so this is the yarn, it will move, and the due to the movement of hair, movement of the yarn, the hairs will come across against the air drag. Due to the air drag, these hairs will have situation like this, they may lie, they are the alignment may change, and also during the movement the yarn will pass through some guide something. So, this hair will not be straight. So, in that case, if we try to measure the number of hairs beyond certain the projected length, in that case we will have wrong result, because so one hair of this type, this is a smaller hair, this is a longer hair, the hair A is a smaller hair, hair B is longer hair, but this A, the if we try to measure the number of hair beyond certain length. So, this is the length beyond certain projected length. So, this if the projected length is this one. So, A will be counted as a hair, but it will miss B here, because the measurement of number of hairs protruding beyond certain length of the beyond the yarn surface, that is good, the good indication, but the problem comes here if the hair alignment, it depends, the result depends on the hair alignment. So, if the yarn passes through a guide, fine guide, the totally hairiness reading will change. So, in that case the measurement of number of hairs has some problem. So, the main solution is that in that case the measurement of total length of hair. If we measure the total length of hair, then whatever may be the alignment of fibers beyond the surface, that will be totally measured. This will, the system will measure total length. So, the two methods are there, one is measuring the number of hairs, another is measuring the total length of hair. They have their positive point as we have discussed and negative point. So, if we have to, if we test the yarn hairiness using one of these techniques, we have to be careful in selecting the parameters. Okay. So, number of hairs and the length of hairs, one can select one of these. Okay. A yarn may have small number of long hairs or a large number of short hairs or any combination of this. So, that depending on the type of hairs one can select. The problem is then which combination should be given higher hairiness rating. These things we have discussed. Okay. So, these techniques they have got their positive and negative points. Now, we will discuss the various reasons, various causes of hairiness. Okay. First, if we talk about the cotton yarn, the first reason is that it is a maturity. It has been observed that immature cotton results hairiness, because it does not get opened, it actually does not penetrate inside the yarn structure, it remains in the surface and it creates hairiness. Okay. So, in case of cotton 70% maturity of the fibers is needed. Okay. If the maturity is less, so when we discuss the maturity, we have seen around 70% matured fiber should be there. Okay. If it is less, then that causes hairiness. Immature and dead fibers result hairiness, because they do not penetrate inside the yarn structure. Another thing is that uniformity ratio. What is uniformity ratio? That we have discussed. It is the ratio of 50% span length divided by the 2.5% span length, and it is expressed in percentage, and normal cotton it is ranging from 40 to 50%. Now, if the uniformity ratio is less, what does it show? Uniformity ratio is less means it has it contains large quantity of short fibers. Okay. Large quantity of short fibers means those short fiber will not penetrate in the yarn structure, those will not take part in migration, and those will come in out, those will be projected outside the yarn surface, okay, as they will not be taking part in the proper migration. So, if it is less, then hairiness is there. Less means it is a that short fiber percent is more. Next is that raw material. So, it is a micronear. So, after the maturity, then it is a micronear value. So, micronear it is important. If we have uniform micronear, then the total or most of the fiber will take part in the yarn structure part. But if micronear varies, if the standard deviation or CV% of micronear or range of micronear increases, then that what does it mean? It means that it has got a coarse fiber along with the fine fiber. So, if it is a mixture of coarse and fine fiber, then the coarser fiber will have tendency to come out from the yarn structure and produce hairs. So, the micronear range is in for cotton. So, normal say cotton say for with 4.2 micronear, it is a plus minus 2 is the range. If it is within this range, then the problem of hairiness is will not be too much, that is the acceptable range, but if it is more. So, it has been observed that micronear value of 4.2 plus minus 0.6 results in increase in hairiness, which is used in flannel like fabric having soft feel. So, this has got its use. This if we want to have some fabric which has got flannel like feeling, then we need cotton with higher variability in micronear. In some, if we need this type of fabric, it has been actually one can always try to mix two different varieties of cotton with different micronear value, then we can create hairiness. So, if the hair micronear value ranges too much, then it will create hairiness. And another problem is that hairiness will result low yarn strength, because if the hairiness is less, means the most all the fibers are inside the yarn structure, okay, no hairs. So, that means all individual fibers will take part in the tension, in the strength, it will individual all the fibers will take their give their contribution. But if we have high number of hairs, very high number of hairs. So, hairs, this hairs protruding hairs will not take part in the strength, but will take part in mass. So, the total linear density of yarn, say both these yarns linear densities will be same, but the effective number of fibers taking part in strength will be much less in case of the yarn with higher hairiness. So, effective hair strength of this yarn will be low. Then problem, there is a major problem in sizing. So, if there is a hairiness, so the yarn is fuzzy with high amount of hairs, then what will happen? So, if we apply say size material here in this yarn, if we apply size material, so size will be applied here as well as it is directly in contact with the surface, they will penetrate inside the structure. So, which we actually want, okay, that will create required characteristics. But here in the yarn with higher hairiness, if we apply size, this will be actually blocked by the hairiness in the surface and size will not penetrate inside. So, yarn quality, yarn strength and other quality parameters will get affected. It will actually create on coating, this stiff size coating at the surface, and during and the yarn will be very stiff, and so that this size coating will be removed during weaving process and the higher breakage will occur. So, that the sizing process needs hair less quantity of hairiness. So, if yarn is fuzzy, size material will not penetrate to the required amount and a greater amount will accumulate on the yarn surface, okay, and coating is more and penetration is less. So, that will create, we in sizing penetration is very important. If it is only coating in the surface, that will after drying this coating will be very stiff and they will come out during weaving operation, and then the yarn will be as like unsized yarn and it will immediately break. So, higher breakage will occur if the yarn is hairy. Okay. Shading problem is there. So, if the yarn, suppose we are using 2 ply yarn, double yarn where sizing is not there, In that case, in case of air jet, cleaner shade. So, total clear shade is not produced, which is important. Okay. Similarly, if yarn density in the fabric is more, like warp, in warp number of warp thread is more, then consecutive threads during up and down motion, the due to hairiness it will create higher friction, and that will not actually, that will not allow clear shade formation, and breakage may occur. Okay. And it is a wearing out of the of different machine part, like drop wear, heeled wear, for any other different machine part through which the yarn passes. Due to the hairiness, it will actually this it will damage the machine part, and also in a knitting the knitting needle will be worn out and quickly, and it will create the problem, maybe it will damage the fabric also. And obviously, fabric will have poor appearance, that I have already mentioned, due to unequal reflection, okay, uneven reflection. Like one this is one fabric with a clear surface, okay, this is fabric. Without any hairiness. This is another fabric with large number of hairs on the surface. Now, when light comes, this fabric, clean fabric with will have regular reflection. So, that will create the shiny nature, but here this will create a random reflection. So, that will make the fabric surface dull in look. Okay. So, fabric appearance will be poor, and also it will have the peeling and many other effects. Okay. Now, we will see the measurement techniques, how to measure the hairiness. Okay. So, that it is a undesirable property we have discussed, and it gives indication of the problem of prickliness. Okay. It creates problem of prickliness, and the measurement of hairiness is actually dependent on the method chosen. Okay. That we have discussed already, and also we have mentioned it is not possible to represent hairiness with a single parameter, because the number of hairs and length of hairs both vary independently. A yarn may have a small number of long hairs or a large number of short hairs, or any combination of that. So, the problem is then which combination should be given higher hairiness rating. Okay. So, that different combinations I have discussed, that measurement of hairiness in by measuring the number of hairs or by measuring the length of hairs will create different problems. Okay. So, we will stop here, we will continue in the next class, when we will discuss all the measurement techniques of yarn hairiness. Thank you.